All right, everybody, welcome back to Machine Organization and Programming. We've got Lecture 8 today. I'm going to just jump right in. We're going to be talking about linked lists and more about pointers and how they're used. And I'm going to start out with a brief review of structures. Okay, so I've just got a quick example that I pasted up here. Please remember that when you are creating a struct, this is sort of just a container that encapsulates a bunch of data. So in this struct right here, I'm creating struct person to hold some data about a particular person. In this case, I've got a character array for their name and an int for the ID number. And over here, I've drawn like a little schematic version of this where I've got some space in memory. My variable here, I've just labeled name. I've got Mike in there. And then my ID. Please don't abuse my ID number if you are out there stealing identities. Okay. So anyway, I want to ask you just a couple questions. How many bytes does this struct really need? When I create one of these, if I go down to main and create, actually, let's do that. Let's do that right now. No, I want to finish the example. So how many bytes does this need? Let's think about this. I've got 4 characters here and a /0. So it kind of makes sense that maybe I'm using 5 here, and then an int takes another 4 bytes. So I'm only using 9 bytes total. But this struct actually reserves 100 bytes. So 100 bytes here, and then 4 more for the ID. So it's really using 104. So there's just a whole bunch of empty space out here after that null character. Okay, so the next thing I want to highlight is that structs can actually have other structs inside of them. So here I've just added some more code. So I've got my struct person right here, and I'm adding an address for my person object. So, or person struct. So struct address is how I create an instance of a struct. I'm calling it address inside of the struct person here. And I've got a description of that address. So my address has a street name, again 100 characters, the state name 3 characters because we need to reserve one for the null character, and an int zip code. So next question is, how many bytes does this struct need? All right, so the top part up here was 104. And then the address piece of this is going to be, there's 100 bytes, there's 103 bytes, and then int is 4, so 107 bytes. All right, that's the absolute minimum. In memory, it's going to waste a little tiny bit because I'm not actually, so every time I start something, it needs to fall on a byte number that's divisible by 4. We'll get into more of that at the end of the semester. We just want to point that out. So when I start storing this, well, the street here, 100 is divisible by 4. So that means the state will be immediately following that, no wasted space. It's only reserving 3 bytes, but then 103 is not divisible by 4, so it's going to waste 1 byte. And then we'll have the zip code after that, which takes 4 bytes. All right, so what did I get total? 108 plus 104 is 212 bytes for this struct. Okay, I've just jumped back over onto a CSL machine where I've got Vim open with this code. I kind of want to just go through. So I've declared my person struct here. I've got my address struct up here. And the person struct contains an address struct, okay, with the name ADDR. Now, I've got to put them in this order because as the compiler reads this, it includes that, then it reads address. And as soon as it reaches this line, it knows how many bytes it needs to reserve for this struct. If I put person first and then address, it would get to address and then not know how many bytes to reserve and would crash or generate a compiler error. Okay, now just a quick review about accessing structs. So down here in main, let me see, am I in insert mode? Am I even on the right screen? There we go, insert mode. I can create a struct. So using the name struct person, we'll just call this guy P, short for person. And there, I've created one. Okay, next up, if I want to access these things, the integers are pretty easy. So the arrays of characters are a little more challenging, but that's why I want to do this. Okay, so P, I can just use the dot operator if I want to assign the ID, for example. So put in my ID number to access the other struct. So I can P dot ADR will get me to the inside struct, and then that has a zip code, also an int. So that is equal to, we'll go with a zip code. Okay, so the integers are pretty easy. Now, the problem with the characters is their character arrays. So this is basically a pointer to 100 bytes in memory. Okay, I would love to be able to just do something like p dot, let's see, name equals blank. This would be awesome, but that's not going to work. So this is a string here, and this p dot name is the first byte in memory where that string is stored. So I'm either going to need to loop through all of the characters in this string and assign them one at a time with, brackets. I could do this. Character 0 is M, but that's kind of a pain. So C provides a string copy function that we're going to use here. So just real quick, I want to demo this. The way this works is I'm going to use string n copy. This is going to copy n bytes, and that's where that n comes from. It's a little safer than the string copy without the n. And this function just takes the destination, so p dot, let's go with name, and then I need to give it the source, Mike, and then the number of bytes that I want to copy. So if I put in 100 here, that's exactly how many I've reserved for the name. After the end of this string, it'll MIKE, then it'll put in /0, and then it's just going to fill the rest of it with \0 characters. All right, so that's all there is to it. Oh yeah, one more detail. Up at the top, that function is found in string.h. Okay, that's all I want to do here. Oh, do I want to do one more? Yeah, I want to do one more thing. Let me compile and make sure that it compiles. Yep, it's not going to print anything out. I didn't do any of that yet. All right, just a little real quick review using pointers and structs. So if I create a pointer to a struct, so this is a struct, RCT person, I need the star to make it a pointer to a struct, so a pointer to a person, and then I need to assign it to an actual struct. So I'm going to do that with the address of my person P, so I've created that up here, and now I have a pointer to that. Now if I want to access the members of that struct, like for example the ID number, I can use pp as that pointer to the struct. My arrow operator takes the place of dereferencing and the dot without having to worry about the parentheses and the precedence problems. That was kind of hard to say. And then I can assign this, let's see, ID equals a new number. I'm going to go compile and make sure I don't have any typos. Yeah, that perfectly works. All right, that's all I want to do. I want to keep this short. I would encourage you guys to go download this code and try printing some of these things out. Try experimenting with string and copy. And I realized I hadn't covered that yet and just figured I should do that real quick. All right, so next up, I want to talk about linked lists. So all right, just a quick introduction to linked lists. A linked list is nothing more than a data structure that we're going to use to hold some data. Just like an array was used to hold, like an array of integers was used to hold some numbers, a linked list will hold data all of the same type. So here's the idea. It's a little bit different from an array. So an array is going to be just a contiguous block of memory where all of the elements are stored next to each other in memory, and we can access them with the bracket notation and an index number. In a linked list, it's a little different. So we're going to have a block of data, and that block of data is going to also contain the location of the next piece of the linked list. So to go through a linked list, we look at the data, we look at next, and then we follow that link to get to the next piece. It makes it really easy to add things like to the end or to the middle of the list or even to the beginning of the list. If we want to add something to the end of the list, we just take this next, create a new object, have it point to that, and then we've got the new one. It's also quite easy to add things to the middle. Oops, forgot this. Somewhere in when we create the linked list, we need to keep track of where we stored in memory. So there's always a head pointer that points to the linked list. All right, and really easy to add things to the middle because I can just create a new object here, a new struct in C, and rearrange these pointers so that as I follow this list, now they're in the right order, in this order. If I were to do this with an array, I would need to first go and copy all of the stuff at the end down one spot, and then insert the new piece. So that can be a lot more work. It makes insertion really quite easy. All right. So in C, if I were to do something like this, similar to what I might do in Java, just create a struct. I'm going to call this node because the linked list is composed of nodes that have both data and they know where the next node is. So that's going to be struct node next. The question I have for you guys is, will this work? So look at this for maybe a few seconds, pause the video if you need to, and come up with a yes, no answer for me. All right. The problem that we're going to run into is when C compiles this, it's going to go through, it's going to grab standard IO.h, copy that in, then it's going to say, okay, we're defining a node. So it starts going through, all right, so that's going to have data. I need to reserve 4 bytes for that. Then I need to reserve something, some space for struct node. Oh, I don't know what that is yet. It hasn't gotten to this closing brace with the semicolon on it. So it doesn't know how much memory, and it's going to fail to compile right there. So the secret that we're going to use to get around this is that pointers. So there is a lot of feedback from this class over the last couple of years that we need to do more with pointers. So assignment 2 is going to be around 2-dimensional arrays with pointers, and assignment 3 will be focusing on linked lists. So hopefully you guys by the end of this class feel like you've mastered this idea. But here's what's going on here. So instead of actually creating a struct node struct inside of here, what we're going to be doing instead is creating a pointer. So as C is compiling this, it says, aha, pointer, I know exactly how big pointers are. All I need to do is reserve some space. And then that'll be just fine. And then we can use these pointers to point to the next element in the array, kind of like I was hinting in my slides just a few seconds ago. All right, so I've just jumped over into Vim to start coding some of this stuff up and talk about it as I go through this. So the very first thing we're going to need is actually that head pointer. So to do that, I've got my struct node data structure up here with a pointer to next. But what I need is somewhere to start, that starting point, so I can store the list in memory. So I'm going to call that, it's a pointer to a struct node. So struct node pointer, and I'm going to call this head. And because I don't have anything in there yet, I have no data, I'm creating a pointer, I'm going to assign it to null. Okay, pretty straightforward, I hope. The next thing I need to do is I'm going to create an actual node with some data in it. So this is going to be struct node, and I'm just going to call it first right now. This is my first piece of data. And now when I do this, what I really need to do is create this block of data. I'm going to do this, so I'm doing this in main, but I'll be moving this to a function in a second. So I want to create this on the heap so that it's not destroyed when the function ends in my create it. So I'm going to use malloc to go ahead and grab some memory, and what I really need is a number of bytes. So I don't actually need to worry about how many bytes my struct has. It's too much. It's got 4 for the data because it's an int. It's got another 4 for the pointer, but that depends on the machine. So what I'm going to do here is just call size of, and then I can give it struct node, and it'll figure out how big it is. It needs to know that anyway. So once I've done that, I've created some space in memory for that first node, and then to go ahead and put some data in there, I can just do first. It's a pointer, so I can use the arrow to access this, and let's see, how about we put data equals 10, and that pointer to the next object. I don't have another object yet, so we'll just set that to null. And just tab all of this over so it's starting to look good. Okay, last thing I need to do in order to make this a linked list, it's semicolon, is make sure that my head pointer now points to this first node. So that's pretty straightforward. All I need to do is say head is equal to first. Okay, I'm going to jump into PowerPoint and make a slide with a diagram of what's going on here. One sec. All right, so the way this works, if I just go through that code, looking at sort of a generic memory model here, I've got the stack here and the heap over here. In that very first stack frame, main, PowerPoint capitalized it for me. All right, pretend that's lowercase. The first thing I did was I created a head pointer to point to my linked list. And initially I set that to null. I'm just got some memory addresses here. Let's just pretend that this is at memory address 1000. The next thing I did was I created another pointer to a node, and this one I used malloc. So that's going to go reserve some space on the heap. So let's pretend that this pointer happens to be at memory address 2000. That's up to the compiler to decide. And when I reserve some data on the heap, let's assume that very first address where my data is stored is 3000. There'll be a pointer over here. Initially, it's not allocated. It's just garbage or whatever was in the memory from before. And it returns that pointer, and that gets stored in my variable first right here. Okay, the next thing I did was I assigned these guys some values. I put in a 10. I put null in. I did those as two separate steps. It's up to me to fill in the data. Okay, and then the last thing I needed to do was to make sure that my head actually pointed to my linked list. It had been null, so all I did was assign the value of the very first, my first node to head. And now head is a pointer that points over here to my data on the heap. All right, let me jump back over to the code. All right, so I think we're off to a pretty good start here. We've got our first node in the list, but I don't want to have to hard code all of these in main every time I do it. I want to write a function that will just add another node to the list. So let me jump in here. Insert. What I'd really like is something that, let's append a node to the end of the list. So I would like a function that will append a node. All right, so let me see here. It's a function. It needs a couple things. We need to know what list to put it in. And to do that, I'm just going to pass in the head of the list. Okay, perfect. And then I also need to know what data to put in. So let's give this next node the value 20. That should be good. All right, so let's take a look at writing this function now. So something return type. I'm just going to leave that as a question for a moment. And we'll come back and fill that in. Append is my function name. And now I've got head and data. Okay, let's think about the types of these. Data is easy. That one's just going to be an integer. Now head, I can actually just read it from right here. I've declared it as a pointer. It was to null a struct node pointer. So that's exactly what I'm going to need right up here. Struct node pointer head. I'm going to go ahead and write the function entirely right here, rather than using a prototype and putting it at the bottom, so that I can see main while I'm doing this. Okay, so first, there's a couple things we need to do here. The first one is to create the new node. And then we'll need to make sure that the pointers are all lined up in the right spot. So, and that might not be the best way to say that, but let's start off with creating the new node. So when I create a new node, this is going to be, well, it's a struct node, and we'll call it next node. How about new node? New node. I like that better. New node. And this is going to be a pointer to a node because we need to go make this on the heap. So that's going to be requiring malloc and size of struct node, just like we used down here when we created the first node. Okay. So once I've got a new node, I can put that data in. New node data equals data from right up here, the parameter I passed in, and new node next equals, so this will be the last element in the list if I'm appending it. So that's just going to be null. It's not going to point to another element. Okay, so now a couple of things. I need to figure out how to rearrange the head pointer if I'm appending a new node. If I don't have anything in the list already, if the list is completely empty, like if head is actually equal to null, then all I need to do is return this new node. So this is one way to do it. There's several different good options, but here's one. Let me just put this in code. I can return the new node, and then if I'm returning a new node, that means I need to make two more changes. this is going to be returning, let's see, this new node is of struct node pointer type. So struct node, I'm going to put the star right next to that to tell me, to just like make it clear to me that this is a pointer. All right, and then finally, when I call append, that'll be returning this pointer to the very first new node, and I need to call head, assign it to head. Okay, that's one way to do this. All right, let me just make sure I didn't make any typos. So right quit, we'll go up here, GCC, linked list dash 132, all the warnings, and I forgot the dash O. There we go. All right, what did I do wrong? Oh, implicit. I need to include standard lib to use malloc. One second. All right, now it's going to work, right? Warning control reaches end of non-void. Oh, I only wrote the one style of the if. All right. There we go. Okay. All right. So I forgot to do the other half of the list. So else, we'll put a little block right here. So if the list already has some stuff in it, I want to put this at the end. So I need to go grab the pointer, the next thing from the last element in the list. Okay. So to do this, first thing I'm going to do is I'm going to start with the head and just traverse the list until I get to the end. So the pointer that I need is head, and I'm just going to make a copy of that real quick. Struct node, and we'll call it current as we go through the list. So current node, we'll just assign that the head value to it. Okay, and now I can just traverse the list, and that's pretty easy to do. While current node next is not equal to null. And I think I need to go draw a picture for this one. But anyway, while it's not equal to null, current node is just going to be equal to the next node. Let's see here. Current node equals, yep. So this will advance my current node. Current node starts out the same as the head, which points to the first node. And then I'm going to grab the next value from that first node and reassign it to current node. So now it'll point to the second one. So looks good. And now when we get to the null value, that means we reached the last element. And all I want to do then is say that current node next, so this is the next pointer in the last node in the list, is now equal to the new node. And that should do it. Okay. And then because I'm returning something, we want to return head, because we want to keep the start of the list exactly where it is. All right, so that looks pretty good to me. Let me go and see if it compiles. Yes, okay. Now I just want to clean this up a little bit. I'm a big fan of not having extra code and shortening this up. It just makes it fit on the screen better, and I really enjoy that. Okay, so because my if block here ends in a return statement, I don't actually need the else. So I can delete this line, I can delete this line, and I can move all these back over. Oops. Okay, delete. Okay. So that looks pretty good. Oops, I moved this one over when I didn't mean to. Timeout. There we go. So if it's null, return it. We're done. And then if not, we just continue with the rest of this code. So we grab a copy of the head. We traverse the list. When we find the last part where it's null, then I reassign that current node next to the new node that we just created up here. All right. Let me just make sure this still compiles. All right. So next thing we need to do, I need to know that this is working. So I'm going to come up with a print function. And before I promised to go to PowerPoint and make a picture of this, let me do that first. All right, so here's what's going on in the memory. So I've just written this append function. So in main, the only thing I care about right now is the head variable. and that's storing the address of the very first element, the very first node, which is on the heap. Okay, and so that's got an address of 3000. I just put it somewhere. It doesn't matter where that is. We never use that number. Okay, as soon as we call the function, it adds a new frame to the stack, and the parameters I'm passing in were head and data. So, and everything in C is called by value. So it takes this number right here, 300, and actually copies the value. So these two heads are different. They're not the same. This is a different memory location. I've got this. Timeout. All right, all better. This is a different memory location. See, 5,000. This one's at 1,000. They're different variables. They just have the same data and point to the same node. Okay, the next thing we did is went ahead and created a new node. So this was the code that did this. We're using malloc. So it reserved some space over here on the heap. I've got this at 7,000 and returns the address where it's stored into that pointer. So I've got my new node pointer at 6,000, and that value pointing there is the address of the data, 7,000. Next thing we did is assigned the data, and which was, I believe, 20, and reassigned the next pointer to null, because this will be the new last node in the list. And the last node always points to null. All right, the next thing we needed to do was rearrange all these pointers. This one in particular needs to point to the last member. So now this is the first member, this is the last. It needs to point down here. So we need to make that address 7,000. So when we did that, first we made a copy of head. So right here, this is 3,000. This is the very first piece of the data. And we made a copy of that. I called it current node. I didn't have room here. I just shortened that. And then this is going to, while current node next is not equal to null. So when we insert the very first one, this thing first looks at the data and then looks at the next pointer. If it's null, then we're just done. We found the last member of the old list, and we need to append the new one. If it's not there, if this is some address, then it's going to just take the next jump and check out the next pointer. If that's an address, it's going to take the next one until it gets to the last member, which will be null. All right, after that, we're down here on this line, current node next equals new node. So that new node right here has the address of this new last element. So all we're going to do is reassign this pointer right here to that memory address, just like that. Now it's got a 7,000 in there. And finally, we're going to return this head variable. The reason we did that this way was because it looks like it doesn't matter. Head didn't change. All we did was add something to the end. But had this list been empty, head would have originally been null, and we do need it to point to the very first element. So that's why we're returning head. So it's going to copy this 3,000 into the return value and end up back here in head. Okay, I really need to know that this is working. So the next thing I want to do, I want to print it out. So I'm going to just write a function that prints out the entire list. Print list. Okay, and the only thing this really needs is the list. So I need the head pointer to get passed in. And now let's think about the type of the head pointer real quick. That is a node. So it's a pointer to a node. So I need struct node pointer. There we go. Now from here, all I'm going to do is go through the entire list. So if I'm going to be traversing the list, we use a while loop. And what I really need to know is, well, head is not equal to null. Okay, that when head is equal to null, then I've got the very last member of the data. From here, we'll print it out. Let me throw some brackets up there. Wait, print. Printf. And let's just print out, we'll do the data, and we'll give ourselves some spaces, and then this is going to be head dot data. I need the other arrow. I need the arrow. Head data. Does that make sense? I think it does. All right, and then we just need to advance head to the next piece in the list. Head equals head next. Okay, and I can do this. This is not going to modify the head variable outside in main. It's not going to change that one because it gets its own local copy. There's no reason to make a copy here. I can just use this variable. I could have called this current instead. That would have been, maybe that would have been a little more clear. All right, and then finally, after I'm done going through the whole list, printf, just throw a new line up there so that this looks good. All right, let's see if this works. Did I put all the semicolons in? They look good. All right. Oh, it compiled. All right, now let's see here. Oh, I never called print. I put it in but didn't call it. Let's do that. Okay, so down here in made, let's see. Let's call it after we add our first element. So print list head. And then we added an element, print list head. Let's give this a try. There we go. Compile. Whoops, what did I mess up? Oops, I capitalized it. Whoops. YP. There we go. Compile. Oh, I still messed it up. All right, I got this. Totally the last mistake. Printf, printf. YP. There we go. All right, excellent. Check that out. Okay, so the first thing it did is I added 10 and printed that. And then, interesting, 10, 20, 10, 20, 20. I thought I only added one. What did I do wrong? Oh, I did add 20 twice. All right. Let's make that 30, just see what it looks like. Linked list. There we go. So the first time, I've only added just the first element, it prints the 10. Then I use my append function to add a 20. So there's 10 and 20. And then I used append again to add 30. So 10, 20, 30. Let's I want to do a little bit more to make this look like a linked list. So a little decoration. All right, up here while I'm printing. So let's see here. I'm printing out the number, but I'm also going to print out the, insert. Print out the address too. So star P. This will be the address of next. And then it's a linked list, so we'll add a little arrow to get to the next piece of data, the next node. And here we need head dot next, head arrow next. All right, let's take a look at this and see what this looks prettier. Okay, so yep, 10. When we added just one element, I have a 10. It's pointing to null, which is printed as nil by printf. And then after I've added the second element, this is now going to be pointing to the address where this data is stored. And then 20, and again, the last is always nil. And then this should not have changed. This should be the same number pointing to the 20. This is going to be the next one pointing to the 30. So these addresses, the OX577 group, are on the heap. Let's see. We've got 577B35C0 and then D0. Okay, so I only had two things there, right? These are actually 4 bytes apart to go from C to D. And I've only got two things in each of my nodes. There's an integer, which is 4 bytes, and a pointer, which is 4 bytes. And then because I'm allocating something on the heap, it's probably reserving some space to take note of the size of that reserved memory allocation. So when I free the memory, it knows how much to reclaim. All right, so I just want to keep talking about adding some functions that are really common to linked lists. And the next one I'm going to do is deleting the first element. So actually, typically what you'd see with a linked list implementation is a pop function that would remove the first element and return the value that's stored there. It would return the data. So in this case, I've got my linked list here pointed to by the head variable. The first thing in the list is the 10 right there. And so this would remove this element and return 10. Now, in the previous function, when we were appending, we were returning the variable head. And we're not going to be able to do that this time. I'm actually not going to bother to return the 10. We'll just keep it void. But I wanted to talk about a little bit different way of implementing this so that I can actually make sure that my list gets changed without having to worry about reassigning head. So at the end of this list, this node is going to be gone, and the head pointer should point down here to the 7000 address where I've got the 20. That's my goal. So the first thing I need to know is I'm going to have to pass something in to the function. It needs to know where it is. But what exactly am I going to pass in here? Let's give that a little bit of thought. So if I make a copy of this and I can't return it, there's no way that I can reassign this. So the secret is pointers. So what I really want is for the data that I pass into my function to be the address in the main stack frame where I'm storing the arrow here, or the pointer to the data. So this is going to actually contain 1000, the memory address here, so that I can access something outside of the function. So let's go ahead and take a look at this in code and just get this started. All right, so here I'm back in Vim. So I'm going to be writing function delete first. It's going to take some parameters, look at some curly braces. All right, I've already told you guys that I would like this to be a void function. I don't want to have to use return the pointer. I want to be able to return data, if it's a pop function or something. And I want to teach you guys a little bit different way about accessing things. So first thing, I'm going to be passing in the head pointer, okay? And this is a pointer to head, so I need a star there. And the type of this is already struct node pointer. So just like we can see up here, struct node pointer. Right, I'm creating it right here, struct node pointer. But what I want is a pointer to this pointer. So that's why I've got 2 stars here, and I'm going to write it like that. This is probably confusing. If you need to hear that again, rewind one more time. Okay, so now I've got what I really need to do now is all I need to do is reassign that head pointer to be pointing to the second element instead of the first. So in fact, let me do one more little thing here. I'm going to call this p head because it's a pointer to head. Yeah, maybe that'll be more clear. I'm not sure. So anyway, to access that, I'm going to be using p head, but I need to dereference it to go follow that address. And then I need to reassign that variable. So I'm going to assign it to the second one. And that is stored in next. That's where it would be. But this is actually the variable I passed in is phead, and I need to dereference that phead. And then because of precedence, we need some parentheses. Okay, that was complicated. I'm going to say it one more time, and if you need to, then you can rewind the video and go through it more if you need that. All right, so here's the idea. I'm passing in a pointer to this pointer to the list. Okay, now when I'm using this, I actually want to get to this piece right here. I want this. I want to be able to modify that. So I need to dereference my pointer to a pointer to get to this much. Okay, and this is what I'm going to reassign. I'm reassigning the head pointer to a new pointer. It's the pointer to the second element, and the pointer to the second node in the list is stored in that first node in the list. So, and it's the next variable from that first node in the list. So to get to that first node, I am simply going to dereference phead and access next. Now the arrow and the star has a very high precedence, so I need the parentheses here to say dereference it first, then go grab next. Otherwise, it'll use this one first and try and go get the next from the pointer, which doesn't have that data member. Okay, so this is sufficient to remove the first element. So let me just test this much out. So delete first head, and then we'll print out the list again. Do it twice. Let's to make sure this works. Find all my typos. Yep, I made it first. Made a delete first. Oops. Spelled that wrong somewhere. Let's go fix that. Okay, done. Try that again. Oh, different problem. Passing one argument from incompatible pointer type. Oh, right. I made another mistake. Okay. So when I call delete head, what I'm really doing is I want the address of head. Remember that diagram I had in PowerPoint a second ago? So to do that, when I'm passing a pointer to a pointer, I need to give it the address. All right, I totally got this now. That's got to be enough. Yes, it ran, or compiled. So now we'll just run the code and see what we get. Okay, so the first thing we did was we added 10, printed out. We added 20, printed that out. Added 30, printed that out. So this would be after we've deleted the very first element. So the first element was a 10. It's gone. Now this 20 is the second element right there. And then we called it again and deleted that first element yet again. And now the only thing that's left is the 30. All right, let me jump back to the code. All right, I meant PowerPoint. Jump back to PowerPoint. So after we've done that operation, we've reassigned this head variable to point to the second member of the data. Now the problem is I've still reserved this space on the heap. This is known as a memory leak. Can be a huge problem, especially for a code that's going to run for a long time. Here I'm only wasting 4 bytes of data, but terrible practice. I need to go back and clean this up. So to do that, we need to make sure that we can delete this after we've rearranged all of these pointers. So one moment while I jump back to Vim. Here we go. So all we've done is reassign the pointer. Next we need to call free to free up that memory. So piece of cake, right? Free. What do I free? I don't have a pointer to it anymore at this point. So I need to make a copy of that. So let's go up here, and before I do any reassigning at all, what I really need to do is make a copy of that. So struct, it's a pointer to a structure node, and that's going to be, oh, let me think about this. Don't screw this up, Mike. So this is a pointer to the head variable. So that's the address and space in main. So I want to dereference that to get to the first data piece. Let me go through this in PowerPoint and show you what I'm really trying to do. All right, so at the beginning of the function, this is what the situation looks like. I've still got head in main. It's pointing to this first element. When I make that copy, so I'm creating a variable first. PowerPoint capitalized it on me. Okay, anyway, what I really want is to know that this is pointing to this memory so I can free it. So to get there, I'm using the pointer to a pointer to a node that I passed in right here. This is 1000. The star means go grab the value here, and that's the one I need because that's going to point to this data right here. All right? So that's what I'm doing right here with this line, that one line, which needs a semicolon. There we go. So now I've got a copy of that, and then I can free the data stored in first. Okay, so that's going to reclaim the memory for the first node. All right. Yep, that looks pretty good. Let's do this and just make sure that it still works. Oh, I meant phead. All right, where was that? Delete first. Yep, there's one right there. There we go. And we'll try running this. And it still works. Okay, 10, 20, 30. Perfect. The last thing I want to do is make sure that I'm not deleting things if the list is already empty. So just one real quick check. Right up here. Right up here. Yep. So if we'll dereference first, or phead, dereference phead. So that's going to be pointed to the first data now. And then I want to look at the next, if that's equal to null. Now the problem, I've got one more issue here, precedence. So this will happen first. So I need to dereference first to go grab the first node, and then I need to look at the pointer. If that's equal to null, then we're just going to return. Don't delete anything. All right, let's make sure that still works. All right, cool. Oh, I never actually tested it with an empty list. So let's just do this. We'll just grab these 4 lines, print it out again, and test it with some real... Whoops, I made a mistake there. Look, it never deleted the last element. I think I know what I did wrong. Let's go take a look at this. So right here, I'm actually looking at this piece right here. If this is null, then I'm exiting. What I really want to know is if this is null. I'm grabbing the wrong one. Apologies, guys. Let me just make that real quick correction, and we'll be on our way. All right, so instead of that one, instead of next, I just want to know if dereference p head is null. Okay, that's going to be this piece right here where I've got OX 3000. If that's actually null, then the list is already empty. I don't want to make any changes. I can just exit. All right, let me run that and make sure it's still working. All right, save it, quit, compile, run. There we go. And my print function didn't actually print anything up because the list was empty, but it did put that new line in. So I'm looking at blank lines there after the list, after we've deleted that last element. All right, guys, this is going to do it for me today. I hope everyone is enjoying the course. Please remember that P1 is due this evening, and then P3 will actually involve linked lists. So you guys get some practice adding more features and working with pointers and it's exploring, watching your program fail to compile and give all the same error messages I'm getting. When I make mistakes like this, I want to make sure that I show you guys and kind of explain the error messages. So thanks for bearing with me while I struggled to figure some of these things out today, and try to make it as clear as possible. If you have any questions about this, it is a hard topic. Go ahead, put them on Piazza or come to office hours. All right, I'm going to go edit this video, get it rendered, and throw that up on YouTube for you guys. All right, have a great day.